Good morning. So you should have just watched the video that explained the PowerPoint notes on surface area. And if you did, you would know that surface area is going to be calculated by adding up the area of all of the outside surfaces on a 3D object. So on Schoology, I have a copy of all the formulas you'll need. And this sheet is going to contain the volume formulas, which we'll get to later in the next unit, and the surface area formulas. And this sheet is something that you could probably just print out or make a copy of so that you have it with you at all times. So just going to go through quickly. For the next unit, we're just going to be looking at surface area. And because it has the word area in it, and area is units squared, all of your answers for surface area will be units squared. So area of a square rectangle, base times height, area of a triangle, 1/2 base times height. Something to note when you're dealing with a triangle, the base and the height form a right angle. Okay, so if you're ever not sure which is the base, which is the height, look for that right angle, and the base and the height form a right angle. Okay, we know the area of a circle, pi r squared, where r is the radius. We're actually going to need to use circumference. We'll do some problems that involve circumference. Circumference of a circle is 2 pi r, or pi times diameter. Now, the area of a polygon, okay, so this is going to be just sort of some common sense. What you're going to do if you see a polygon, and we're only going to be dealing with regular polygons. If you look down here, I just have a regular hexagon, right? What you're going to do, and you'll always be given the height or have a way to calculate it, okay? What you're going to do to find the area of this is you're going to say, okay, I'm going to look at one of these triangles. And by the way, these triangles will all be isosceles. And you'll just say, oh, well, this is 1/2, base, whatever that base is, times height, whatever this would be, and you would have information to find that. And that's the area for one of the triangles, but how many do I have? Oh, I have 1, 2, 3, 4, 5, 6, just multiply by 6, and that would give you the area of a shape like this. And that would work for, a hexagon, an octagon, a pentagon, any kind of gon, you would do the same thing. Okay, surface area of a cone. You saw in the PowerPoint slide, the cone actually decomposes into something weird, right? On a cone, you can see that the bottom part is a circle. So the circle formula is pi r squared, right? That makes sense. But you have to add to that this weird thing on the top. And in the PowerPoint notes, it kind of looked like a party hat. So if I unravel this party hat, let's see if I can draw the picture. It kind of looks like weird. It looks like this. Okay, and when you get to calculus, you'll learn a good proof for this, but the formula for this part of it is pi times r, which is my radius, times L, which is something called my slant height. So L would be the height on a slant, so this distance here. This h would be my regular height, right? This would be my slant height. And I'll do examples of these so you'll see. And then finally, the surface area of a sphere. Remember, a sphere is just a ball, so think of like a basketball, right? And let's see if I can draw a basketball, probably not. If you sort of unraveled a sphere and like cut it open, you'd actually see that it would form or would have the amount of area for 4 circles. And I'm going to have you guys watch coming up today a video on Edpuzzle that demonstrates why the surface area of a sphere is 4 pi r squared. Basically, the video is going to take an orange or a clementine and peel the outside and fill the space with 4 circles. So that's how it's 4 pi r squared. So that video is super cool. So make sure you watch the video, make sure you go through the PowerPoint notes, have these formulas on hand with you, and then tomorrow, or you can start working ahead today, we're gonna start actually doing some calculations on surface area. I think you'll find it to be very, very logical. Okay, I will see you in the next video.